Hey there, welcome to a question session here for AP Physics. Patent pending on that title since I didn't think about it. In any event, no, so I'm going to answer some questions related to the stuff we're going over this week, which to be honest, I have not received a bunch. Just make sure that, whatever you want to do in terms of contributing to make sure that you're going to be able to pass the AP test, that you're doing that. I'm going to try not to put any guilt trip on you. I know this is a weird time period. If you noticed, and you should take a look at this stuff, we do have a new test date. I believe it's Thursday, May 14th. I probably said this in a previous video. For your test, it is FRQ only now. I don't know what specific subject it's going to be on. And it's like 45 minutes instead of 90 minutes and all those kind of changes. So, we do have a lot of time, over a month now still to go through and review everything. We have simple harmonics to make sure that we understand. We have torque to make sure that we get a chance to go through. And then I will make sure I go back through at least kinematics to make sure you understand that a little better. I think that that's the best course of action. We'll probably go through a little bit more than that, but that's up to you guys. Just kind of let me know and keep in touch with me. So I did receive a question about kind of how do we isolate some of these variables and what we're doing, and I want to go over that one really quickly. And then I'm going to read through a little bit of the FRQ that you should be working on and should be trying to upload things to and should try to turn it in to make sure that you can do that, right? So one of the questions that I received had to do with manipulating variables to get K based on certain equations, right? So in this case, we're talking about the equation for a period for a spring. So in this case, you'll notice that we have here, I'll try to put it as close as I can, we have here that equation. That is T is equal to 2 pi, the square root of M over K. Okay. So one of the main things we need to know moving forward for anything like, let's say the FRQ, is being familiar with what our variables mean, right? So we know that T, capital T, means period. Period is how long does it take for me to repeat a certain cycle, right? And again, period is very closely related to frequency. How many times per second do I repeat this cycle? And that's going to be frequency, right? And so when you see frequency like hertz, if you see something that's like 60 hertz, that means that 60 times per second that thing is completing a cycle, right? So most things obviously are going to not be are going to be below that. In terms of concrete examples, I guess I should say, right? So let's say that you have the clock on the wall. The clock on the wall goes all the way around the outside edge, but it doesn't do that once a second. It does so, if it's the second hand, once every 60 seconds. So that would be 1 over 60 hertz, right? As an example. So that's what I mean when I say most things. I mean concrete big examples. We're talking about like the light in your house or like the power coming into your house and that kind of stuff. It's got this back and forth motion that it does. It's alternating current. We're actually not going to cover that now because of everything, but alternating current is power coming into your house going again back and forth, and when it goes back and forth, it repeats that cycle really quickly, right? And that would be well above 1 hertz, right? Things like that. So just frequency and period really closely related, right? So frequency is a lowercase f. So again, we need to make sure that we start getting familiar with all of our variables. Because really, that's most of what the test is going to be asking you to do, is recognize where do you have the same variable in multiple places, and how can I isolate out to get that. In the FRQs, to be in particular, they're going to be asking us to be creating like an experiment, which I believe is the FRQ they have for us as an example. And they're going to be telling us like, oh, we need to find this thing. How can we find it? All that really requires us to do is know how to identify the equation, and inside of that equation, we can literally just say, I need to measure for these things. How do I measure for them? And then set them equal to the thing I'm looking for. And sometimes the thing I'm looking for needs to be solved for algebraically, and that's pretty straightforward, pretty easy, right? We'll kind of go through that. So we have this equation period for, again, a spring, and that is T, which is period. How often does this cycle repeat itself? How long does it take, right? Like the moon's period is 28 days, 28.2 days or something like that. All right, okay, so that is equal to 2 pi. I'm sure you know that those are just numbers, right? Pi is just a number. We use a symbol because it's a very long number, but it's just a number. Times the square root of these two variables, again, m over k. And m is just the mass of the thing that we have attached to that spring. And k is what's the spring constant. Remember, the spring constant is a thing that's unique to the object that tells us how elastic it is, right? For lack of a better term. How stretchy is it, right? Cool. So then let's say they asked us to solve for the k. The first thing I would do is I'm going to split those two things apart. That's really the exact same thing. Square root of m over square root of k is the same thing as square root of m over k. And we're going to separate that because I just want the k, right? So what I'll do then is I'm going to multiply each side by square root over k to move that square root over k over to the other side. And I'm doing that to isolate it. So now that all I have to do is get rid of that period, right? And when I get rid of that period, I move the t to the other side. And you can see now I have square root of k is equal to all that other stuff, which you can hopefully see pretty clearly means we just need to square it. Well, again, 2 pi are just numbers, so we can just easily square them, right? And they become 4 pi squared. And then square root of m times square root of m is m, right? And then t times itself is t squared. So we now have this equation pretty easily to go back and solve for what is my spring constant. Now let's say that we had another equation which told me Hooke's law, right? And Hooke's law tells me F equals negative kx. Well, I can isolate the k in that formula. Would say that it's going to be k is equal to negative f over x, right? If we isolated that. Well, now I have two equations for k, and I can set them equal to each other. And you may say, why would I want to do that? Well, I'd want to do that if there was something that I didn't know, right? Let's say that there was something that I didn't know and I need to replace that variable. Well, I could do so by finding out how to replace it in terms of k, and then wherever k shows up, I could go back and pump all of that information in, right? Variable replacement that we did earlier in the year, right? Where I didn't know the time, but I knew that I could find an equation to pump in for the time that would have all these other variables that I did know. And then that made it really easy for us to go, okay, well, now I can isolate these things. Yeah, and so again, you know that a lot of our equations are going to be, can you design an experiment to measure these things? And so just make sure that we're familiar with those formula. Obviously, Hooke's law, F equals negative kx. I just used it here. We need to be familiar with that. The period equations, both period here for a spring and period for a pendulum. And period for a pendulum, I believe, is what the FRQ is about. So I'm going to take a look at two things. So I have to edit this video, my last video, back to back. I didn't realize that when I switched windows that this thing was going to cut me off from speaking. And so I'm going to just kind of cover the 5 minutes worth of material that I cut myself off from, which is not a big deal. If you take a look at College Board, you can find the formula sheet. Actually, Googling AP Physics formula sheet is probably a much easier option, to be honest with you. Yeah, and you can go and kind of see where they have all of those formula kind of listed out for you. And it's actually pretty easy. They have Hooke's law on there. They have the period for a spring. They have a period for a pendulum. And you also have spring energy. And that's kind of all the ones that are related to this chapter. Well, in kinetic energy. You're also going to have your sine and your cosine equations that are on there. So everything that you're going to probably encounter will be on there. And most of what we're looking for in this chapter is going through and finding, how do I locate what I'm looking for inside of a formula and then measure everything else. So it's specifically in reference to this week's FRQ. With this week's FRQ, you are being asked to find G, and you're given these materials. Well, what we can obviously construct with those materials, or at least I hope is obvious, is probably not a spring, right? And we're also going to try to locate in the formula that have to do with this section, where is G? So it's pretty easy to go ahead and locate that G is in the formula for period of a pendulum. I probably don't really have to explain too much more there, but we can construct something where we can have a pendulum and measure for those things, right? So make sure you understand, how do I measure for all of these things? How do I go through and find a good way of getting an exact number for all those things? What I mean by that is, like, use a reasonable piece of equipment, right? That they tell you have some physics measuring stuff that's in this lab room. Well, I need to know exactly how long the string that I'm going to be using is. I'm going to use a meter stick, right? I need to know the mass of the thing on the end of this rope. No, I don't actually, it turns out, because if you look at the equation for period of a pendulum, it's not on there. Yeah, so the FRQ really has to do with that. How do I go through and isolate what I need out of this equation, and how do I measure for everything else? Outside of that, I would think that it's pretty straightforward in terms of what they're asking you to do. If you're running into any issues, remember that we do have our meeting, and just try to keep in touch with me about that. So I think that's anything I had any actual questions on, and even the FRQ stuff I didn't, but I wanted to make sure that you guys got a chance to see this stuff. So you just let me know, and yeah, I appreciate it.